Hello. This video describes the modification that Caleb Drake did to Rob's laser build series. With a little bit of background on what I'm doing it, when I joined the group, I saw lots of references to Caleb's modification. Most of them, I think nearly all of them, were positive comments, but I didn't know exactly what it was. I mean, it looked like it was a linear rail conversion, but it also looked like sometimes it was described as a modification to have a single motor for driving the X gantry instead of just one. Somebody said it was both. I hadn't dug into a lot of detail yet, but I wanted to get my parts on order because lead times was so long. So I really wanted to understand what not to order if I decided to go with Rob's, rather Caleb's design modification. Some of you probably find this obvious if you've built CNC machines before, or certainly if you've already built the Y1200 or Y400 and doing the modification after the fact, or maybe even if once you have the parts in your hand from Caleb or put them yourself. But I just had a lot of questions. Caleb was fantastic getting back with me immediately, but I just had so many of them. I felt bad about how much time he had to spend for how much money I had paid him. So I thought I'd try to pay back a little bit and do a video. Maybe he won't get nagged by customers in the future as much as what he was by me. Let's start by taking off the covers off the original stock design. And we look in there, we're seeing the X gantry is driven by a motor on each side of the gantry. And then we have the gantry rolling on carriages. The rollers are in the V-slots on the extrusions. So you need V-slot for these rails, these extrusions in the stock design. Those aren't required. You could just use regular T-slot if you go with this modification from Caleb. Here we show the modifications done with Caleb's design. Linear rails instead of the carriages in the V-slot. And also we need these new assemblies at the end of the of these extrusions to route the belt correctly inside the extrusion on the bottom and on top of the extrusion on top. There's some more changes we'll talk about as we go through. We go here and look, zoom in back on the original stock design with the motor. This motor, separate motors for each axis, for each side of the gantry goes away. Instead we have this assembly with a rod that connects the two assemblies to drive them both together. You notice there's interference if in the stock design. Easy to eliminate that interference. You just move this rail up. It's about, I think it's 5.25 millimeters up. Anyway, to where it's flush, to where this bracket now is flush with the top of the vertical extrusion. Here's where it was in the original position, and you just move it up this much and eliminate that interference. Here's just another view. I took the side pieces off the assembly so you could see they're ball bearings that are on Caleb's bill of material list. Taking some more covers off. These parts are 3D printed. The gear, the top idler, a toothed idler pulley gear, some spacers. Here's just another one. I didn't. This is not on Caleb's bill of materials. This is just something I drew up as a starting point to how I'm going to drive this with a single motor instead of two on each side. If we go over and look at the mirror number 2, there are some things we have to do different there too. This is in the original stock design. Again, the gantry is riding on top of a plate which is on a carriage that runs in the V groove of the extrusion. In Caleb's design, we have this running on top the linear rail. So everything moved up. In order to keep the head in the same spot, we had to do something different. Let's go ahead and zoom in here. Originally, this mirror assembly had one of the plates on top of the other, and all we need to do is mount that plate on the bottom, and that changes the adjustability range down so that we can get the beam height back to where it was in the original stock design. You have to do something similar in the head. Here's the original stock head, and what Caleb suggests as one potential way to get the head down is to simply buy the Cloud Ray C-Series mount, and in addition to that, you build a custom, you 3D print a new plate here that gets you lets you adjust it vertically farther down than before, so it'll keep the head at the same height it was originally. If we go over look at the tensioners, those have to change too, because now the belt needs to root up higher on top of the rail than it did originally. Take the belt off and we'll look at that a bit. You can see it goes through the extrusion on the bottom and it goes on top. Let me just go back to the other one. Maybe that's better. Through the extrusion on the bottom and on top the extrusion on the top. If I peel off some more stuff, the pulleys, these pulleys are have the bearings integrated to them, so there's no bearings required in the housing. They're, of course, they're on Caleb's bill of materials. If I go ahead and take these shafts, there's two 8mm shafts. This one's 30 millimeters long and 23.8. And if we go here, there's this pulley. This pulley bracket slides back and forth to allow you to adjust the tension. The tension is adjusted by a screw which pushes on this bracket and pulls the pulley as needed to, or pushes the pulley as needed to get the desired belt tension. So I hope that helps somebody understand a little bit more detail than what in a little bit more detail what the modification is. Thanks.